Good morning, ladies and gentlemen. Welcome to this course of Conditioning Program Design. This is week 1, lecture 1, and we will be covering conditioning and its types. I am Colonel Dr. Anup Krishnan, and I am a sports physician, and I'll be taking you through this lecture. I'll cover this lecture as per the following outline: definition, introduction, history, physiology, components and types of conditioning, design and periodization, practical applications, and as always, we will conclude with a take-home message. Let's talk about what is sports conditioning. Now, sports conditioning is the strategic process of using exercises, activities, and proper physical training. Why? To develop and enhance an athlete's physical and physiological capacities. What capacities? Endurance, strength, power, speed, and agility. The goal is to improve overall athletic performance, increase readiness for a specific sport or activity, and significantly reduce the risk of injuries by strengthening muscles, tendons, and ligaments. So, you want to improve performance, you want to improve the readiness for a particular sport, and also reduce the risk of injuries. Conditioning per se is a type of training session that is designed to improve physical fitness and sports performance by focusing on increasing strength, endurance, and power, enabling the body to meet the demands being placed upon it. There are two major types of sports conditioning. There are two major types of conditioning: sport-specific conditioning, which targets exact movements, muscle groups, or energy demands of a particular sport. General conditioning focuses on building overall performance. Let's talk a bit about the historical perspective. During the pre-modern or early developmental era, the focus was on basic fitness. The training was based on improving fundamental physical attributes such as stamina, speed, and strength. And the approaches were very rudimentary and basic. In the mid-20th century, scientific principles started to emerge. The 7 principles of exercise and sports training, such as individuality, specificity, progression, overload, adaptation, recovery, and reversibility, were developed to structure training programs. Individuality means the training program has to be individual and based upon the individual's specific characteristics. The training program should be specific to the motor quality which you're trying to develop. You cannot give an exercise program and forget about it. The exercises have to be regularly progressed in order to build upon the motor qualities. If you do not give any load to the individual, the principle of overload will not be fulfilled, and therefore you have to load the individual beyond the normal basal metabolic level. When there is load applied to the body, there will be an adaptation in the body. This process is called adaptation. However, if you give load and if the body goes into an adaptation state, if you do not give time for recovery, the body will not be able to adapt properly to the training load which has been placed upon it. And the principle of reversibility simply means use it or lose it. If you do not use a particular body part, muscle, or tendon or ligament, the strength gains will be reversed within a short period of time. So these are the 7 principles of exercise and sports training, and these were developed in the mid 20th century. In the mid 20th century, they also started developing something called macro cycles, which we'll be discussing a bit later. In the modern era, from the late 20th century to the present, the concept of periodization came into play. Periodization simply means adjusting load recovery as per the demands of the body and as per the equipment, time and the training program. Simply put, this is what periodization means. We also have a concept called long-term athlete development, wherein an athlete is talent hunted, put into a training program, sport-specific training program, and monitored over a period of time, provided with facilities for improving and maintaining his talent. This is called long-term athlete development. There is now a phased approach to conditioning programs, and they are now centered upon distinct periods. You have something called a preparatory phase, you have something called a competitive phase, and you have something called a transition phase. Preparatory phase prepares the body for training. Competition phase prepares the body for competition, and transition phase brings down the athlete from the competition phase to a baseline state. From the late 20th century to the present, we also have seen the integration of recovery into the training programs. Let's talk a bit about the physiological basis of conditioning. So what does conditioning do? It enhances cardiovascular, muscular, and metabolic systems by increasing something called mitochondrial density, improving the neural efficiency, and improving VO2 max. Now these parameters you will come to know are very important for the basis of sports conditioning. Let's talk a bit about the components of physical conditioning. We have something called aerobic endurance. How long can you run? Or what is the distance you can cover? It is basically a measure of your cardiorespiratory fitness. We have something called anaerobic power. How much can you lift? Basically a measure of your strength and power. You have a component called strength. You have a component called flexibility, and you have a component called agility. These are some of the components which are very important in physical conditioning. There are different types of conditioning depending upon what type of motor quality you are trying to develop. Aerobic conditioning for developing aerobic fitness. Anaerobic conditioning for developing anaerobic fitness. Strength and muscular conditioning for developing strength and muscle hypertrophy. Speed and agility for improving agility and speed. And flexibility conditioning for improving flexibility. Let's talk about aerobic conditioning. What does it do? Aerobic conditioning improves cardiovascular efficiency, improves the VO2 max, and ultimately improves endurance. Basically, it improves how your body takes in oxygen, how your body diffuses oxygen into the blood, how your body transports the oxygen across the tissues, and how your body utilizes oxygen. Methods: long, slow, distance run, tempo runs, and continuous cycle. These are different concepts. We will be touching upon each concept a bit more in the later lectures. So what happens if you subject a body to aerobic training? So there are some physiological adaptations to aerobic training. In the heart, the stroke volume will increase. in the rest of the body, in the muscles, there will be an increased capillary density. That means the number of capillaries will increase in the muscular beds. The mitochondrial density will increase. The number of mitochondria and the size of mitochondria will increase in the cells. All this will lead to an enhanced oxygen extraction and an enhanced oxygen utilization. Anaerobic conditioning basically involves short, high intensity efforts with short, incomplete recovery. The different methods used are sprint interval training, high intensity interval training, and plyometrics. Generally, anaerobic conditioning is not started very early in the training program. You generally want the athlete to reach a particular level of aerobic fitness before you start anaerobic conditioning, because if you look at these drills, most of these drills, if you give it to a raw, untrained person, you will cause injuries. So what are the physiological adaptations to anaerobic training? There will be increase in the glycolytic enzymes. There will be increase in the lactate tolerance, and fast twitch fiber recruitment will increase. We will be talking about lactate tolerance and glycolytic enzymes a bit more in the subsequent lectures. So just bear in mind with the concept. If you subject the human body to strength and muscular conditioning by resistance training, circuit training, and plyometrics, you will have hypertrophy of the muscles, you will have improved neuromuscular efficiency, and because the strength has improved and the neuromuscular system conduction has improved, there will be injury prevention. Flexibility conditioning. Now, flexibility conditioning involves something called a stretching program. As we know, there are different types of stretching programs such as static, dynamic, and PNF stretching. The benefits of undergoing a proper, well-designed stretching program are improved range of motion, improved performance, and reduced injury risk. Now, there are different types of stretching program, and they have to be tailored according to the athlete, the sport, and the peculiar requirements of the training program. Speed and agility conditioning. Basically, you're trying to improve the speed and the agility of the athlete by quick acceleration, sudden deceleration, change of direction, etc. Now, these are drills which are meant to improve the agility, the speed, and something called the reaction time. You may use ladder drills, you may use cone drills, or you may use something called resisted sprints for speed and agility conditioning. Let's talk about something called high intensity interval training as a conditioning tool. A very good tool, but has to be used with a proper scientific bent of mind. And if used smartly and scientifically, it gives a lot of gains in proportion to the time spent on HIIT. Basically, it improves both aerobic and anaerobic systems. It is time efficient and it is effective for sport and for health. Let's talk about something called designing conditioning programs. When you design a conditioning program, you have to understand or keep in mind the principles of specificity, overload, progression, and recovery. We have discussed a bit about this earlier, but keep in mind that these programs have to be designed based upon the sport, the fitness of the individual, and the individual requirements and peculiar makeup. All right. Now let's talk a bit about the application part of conditioning program design. Now, any sport generally has three components which are important: speed, strength, and endurance. Each sport uses these three motor qualities either singly or in combination. There may also be subdivisions of these motor qualities which may be used by different sports. For example, you may have something called speed endurance. You may have something called speed strength. You may have something called strength endurance, etc., etc. There may be a combination of these three motor qualities being used depending upon the sport and the type of the event. Now, generally, what we do before designing a training program or a conditioning program is pinpoint where on this chart your particular event falls. So, for example, if we say weightlifting, it will fall towards the lower end of the endurance, but towards the upper end of the strength and speed. If we talk about middle distance running, high endurance, low speed and low strength. Similarly, you have to pinpoint where your sport comes on this spectrum, and this is the first step towards designing a training program. Once you've decided which motor qualities are important for your sport, then you start designing the macrocycles, the mesocycles, and the microcycles. Please understand, you have to balance the different types of conditioning throughout the season. It does not start like you start with aerobic, then anaerobic, and then you never talk about aerobic through the rest of the season. No, it doesn't work that way. You have to have a mix of aerobic, anaerobic, strength, power, flexibility, speed, etc., etc. throughout the season. And you have to vary the training load, the drills, and the type of drills according to which part or which phase of the training program you are under. If we talk about periodization in conditioning, we must talk about macrocycles, mesocycles, and microcycles. Macrocycles is the big picture plan that sets the overall goal over a season or 1 year. Mesocycles are focused phases, typically lasting a few weeks to a few months, targeting specific goals like building endurance or sharpening speed. For example, this is the macro cycle for the entire year. However, you want that your athlete has to peak here, athlete has to peak here, athlete has to peak for a competition here, and peak for a competition here. Now, this will depend on your mesocycle design. So, you have to take the athlete from here to the peak and bring him down, bring him back up here again, bring him down, bring him back here, up again, bring him down, bring him to the peak here again, and bring him down. Because now the training program is, the season is coming to an end, you have to bring him down into the transition phase. Now, this is the basic principle of a mesocycle design. You have to know when to peak your athlete and when to bring him down. Simply put, this is what you're trying to do. Towards this, you will design your microcycle or your weekly and daily workouts. So your microcycles will be, now this is generally over 3 months, 3 months, 3 months, 3 months. So your this will be your weekly training programs. These are your microcycles. And in the microcycle or in the weekly training program, you will do your day-to-day workouts to fine tune the training as well as to adjust for recovery and performance. Some days your athlete may not have recovered enough for the next day's training load, so you have to fine tune your training load and recovery depending upon the athlete parameters. And then finally comes the individual workouts which you will give daily. Fine. So you have a periodized training program. Everything is fine. How will you monitor your athlete? You will monitor your athlete using some tools. What are these tools? These tools are heart rate, lactate, rate of perceived exertion, GPS, VO2 max, and we will also add two more tools called heart rate variability and resting heart rate and sleep. Every day when your athlete comes to you, take the sleep quality, the resting heart rate readings and the HRV readings. Everything is available on smartwatch based systems nowadays, so it is not very difficult. Sleep quality, the athlete will have to maintain a sleep diary and you will have to take it from there. Lactate, you can do serial examinations of blood lactate levels and you can vary your training load depending upon it. RP is a subjective measure of perceived exertion. GPS based training monitoring systems give you the training load which is being put on the athlete. And you can measure VO2 max and see whether it is improving or not improving over the period of the microcycle, mesocycle and the macrocycle. And you have to track the progress in endurance, strength and power. All this is fine, but it has no meaning if you do not focus upon proper warm-up, proper cooling down, proper sleep and nutrition. If you focus upon all these, it will help you to avoid overtraining and injury. So let's talk about the take-home message. Proper conditioning is very vital for modern sport. General conditioning is important to improve fitness and may be given to the general population also. Scientific conditioning program is given to athletes as per the requirement of the sport. And it is to be integrated into the training program. You cannot have a conditioning program separate and a training program separate without an integration of the two. We have to have an integration of the different types of conditioning into the training program. And sport-specific training program design is vital as each sport has different motor qualities. These are the references, ladies and gentlemen. I strongly urge you to go through them in the interest of better understanding. We have come to the end of lecture 1 of week 1 and I thank you for your patient listening. Jai Hind.